So today we are starting day 5 of chapter 11. We are doing 3 days of notes before our next little break and review. So we'll take notes for the rest of the week. Today is all about adding and subtracting with radicals. All right, do you have the 11.8 section in your notes? Everybody in the right spot? Okay, so a quick review. How would I do something like this? Oh. So why do I only put y's with y's? It's just the rule. Those are like terms. You can only add or subtract like terms. So what is 3y minus 7y? Minus 4y. Good. What about number 2?
13x squared minus 4x squared.
Very good. Gives me what?
9x squared.
Plus. Perfect. What are your questions? Okay, so adding and subtracting radicals is the same idea. We add or subtract the numbers in the front only when the number in the radical is the same. So it's similar to the idea of like terms. Whoop. All right, so here's example 1. 8 square root 11 plus 7 square root 11. Do I have radicals that are alike?
Yes.
Okay. So you add the numbers in the front, like the coefficient. Don't make it square root 22. A lot of people want to do that. It's sort of like the x's and the x's. It doesn't become like x squared or anything crazy like that. The only thing you're adding is the number in the front. The number in the radical just sort of comes along for the ride. Okay? The other thing you want to check is sometimes this number isn't simplified, so then you do a factor tree. Sometimes you have to do a tree first to get them to be like radicals, and then you add. So you got to be aware of the whole tree idea throughout this. All right, here's example 2. So 7 square root 3 plus 2 square root 2 minus 3 square root 2 minus square root 3.
Yeah. Is there an imaginary one in front of that square root 3?
Uh-huh. All right, so what's 7 square root 3? Well, I'll ask you, what goes together? What do I do?
Square root 3 and square root 2.
So the square root 3's go together, and the square root 2's go together. What is 7 square root 3 minus 1 square root 3?
6 square root.
So we'll have 6 square root 3. What about the square root 2's?
Negative 1.
Negative 1 square root 2. Good.
And then can't you make multiple both of them by... Can't you both... Don't they go like to 6? You can't simplify them any further.
Nope, you can't simplify them any further. That's it. That's the answer. Questions? All right. Example 3.
Can you multiply the thingy or simplify the...
So the way you would simplify is you could do a tree for the numbers inside the radical, the radicand, but none of these trees would produce anything that repeats. Like 5 and 5 are both prime. 15, if I did a tree, I'd get 3 and 5, so no repeaters. So none of these simplify. So what can I do instead?
Just add the 5s.
Just add the square root 5's. Good. So what is 3 square root 5 plus 7 square root 5?
10 square root 5.
10 square root 5, and then just keep the minus 4 square root 15 along for the ride. Questions? So none of these at the moment are alike. So there's not really much we can do. What we can do is try to simplify the radicals. So square root 27, I can do a tree for. So it's 3 and 9. 3 is prime. 3 and 3, those are prime. Who's going to come out front?
3.
Who's already out front?
2.
What's 2 times 3?
6.
So this will be plus 6, and then this square root 3 is left over. All right, I can do a tree for 20 or for 98. So it's 2 and 49, and then 7 and 7. Okay, so the 7s are going to come out. What is 7 times the 3 that's already out there?
Negative 21.
Good, so we'll have minus 21, and then this 2 is left over. So the reason we did a tree on this one and not any of the previous ones, there's 2 reasons. The previous one, we already had like radicals. We could just go ahead and start combining. And the bigger reason, the main reason we didn't do a tree is because none of them had repeating factors. If I did the tree, nothing would come out. Okay? These we could simplify. They did have repeating factors, meaning 3 and 3, and 7 and 7. So now that they're all simplified, do I have any like radicals?
Yes.
Yes, which ones?
5 and 21.
The ones with the square root 2, right? So what is 25 square root 2 minus 21 square root 2? 4 square root 2 plus, and then the 6 square root 3 just sort of comes along. What are your questions? All right, example 5. Yes, we need a factor tree.
For that one, can you bring for 3 squared 24? Can you bring out a 2 and then leave it a 6?
Yes, I think that's how it works out. Yeah, so we'll have a 2, pair of 2s come out front, and a 3 and a 2 stuck on the inside. So yes, you're right. 2 comes out, 6 on the inside, but there's already 3 out front. So what do I really have?
6.
Yeah, because these 2s join the 3 out front. So 6 square root 6 is what I get when I simplify 3 square root 24.
Would it be 3 and 50 or 20 and 50?
You could do 3 and 50 would work. I'm doing 2 and 75. 2 is prime. 3 and 25. And then 5 and 5. Okay, so who's coming out?
5.
And there's already a 4 out there.
20.
So plus 20, and then what's left over?
6.
Square root 6. Oh, perfect. Why is that so nice?
Because they're both.
Because they're both square root 6. What is 6 square root 6 plus 20 square root 6? 26 square root 6.
We're going to have plenty of time on the homework.
Questions?
This is way simpler.
Mm-hmm. 105.
Plenty of time.
I know. I might even be able to grade your quizzes while you guys are working quietly and respectfully of those around you. Okay, what do I do?
Trees.
Yes, you need to do some trees. Now, hold on. I just want to pause. A few of you were saying, like, this is really easy. And I agree. However, I just graded, my juniors did this same thing, and everyone says it's easy. And then they get to the test, and they write something like 9 square root 165. Do you see why that's wrong? They'll add these numbers. Okay? Don't be that person. It's not that easy. You know what I'm saying? So don't forget, it does feel easy, but don't make it too easy, because then you'll be doing it wrong. Okay? So just be aware of that. They have to be alike before you can start adding them. All right, so I need to do a tree for 75. What's that look like? 3 and 25. 5 and 5. Oh, I don't know why I'm writing. These are programmed in. Okay, who's coming out? The 5s. Who's already out there? 4. What's 5 times 4? 20. Who's left over?
3.
So 20 square root 3. Boom. Moving along. 90. 9 and 10. Or 2 and 45. 5 and 9. 3 and 3. If you did it the other way, 9 and 10, you should still end up with 2 3s, a 2 and a 5. So who's coming out? 3s. Who's already out there?
5.
What's 3 times 5?
15.
15 with the 10 left over. Okay. 9 and 3. 3 and 3. Who's coming out?
3.
Who's already out there?
10. 30 square root 3.
Minus 30 square root the lonely 3. Okay. Perfect. Why is this so perfect?
Because you can do the 20 square root 3 minus 30.
Good. So we can combine the 20 square root 3 minus the 30 square root 3.
And then you 10 square root.
That gives me negative 10 square root 3. And then this guy didn't have a partner. A lot of times when it's one's positive, one's negative, we put the positive one first. That's not a hard rule that I'm going to force you to follow. So you could have negative 10 square root 3. Just make sure it's plus 15 square root 10. Questions? What did we learn today? Adding and subtracting radicals. All right, here comes your homework.